Welcome to This Explainer. Okay, today we are diving headfirst into what might be Elon Musk's most mind-bending master plan yet. We're going to trace a journey that starts right down here in a Texas megafactory and goes all the way up to, well, capturing the sun's boundless energy. We're talking about a leap in technological evolution that sounds absolutely crazy, like pure science fiction. But, as we're going to see, the foundational blueprints for this, they're literally being drawn up right now.
So let's just start with this massive, totally paradigm-shifting question, one that completely redefines our place in the universe. What if humanity could capture 100% of the sun's energy? Think about it. Right now, our planet just catches this tiny fractional glimpse of the power our star actually puts out. But what if we just didn't have to settle for that? What if we could capture the whole shebang? Well, to answer that, we actually have to start our journey not out in deep space, but right here on solid ground. You see, to conquer space, you can't just build bigger rockets. You need unprecedented artificial intelligence. And you simply cannot build a galactic civilization without the actual physical hardware to run it. Look at this quote from March 2026. It's fascinating because it perfectly sets up the earthly foundation for this massive interplanetary ambition. We either build the Terafab or we don't have the chips.
So, we begin at the micro level with Terafab. This was announced at the old Seaholm power plant, and it's this massive joint project between Tesla, SpaceX, and Intel. The main goal here? To vertically integrate AI chip manufacturing right in Austin, Texas, aiming to produce over 1 terawatt of AI compute capacity every single year. That is a staggering amount of compute. They want to do everything under one roof, from the initial chip design and lithography, essentially printing those microscopic circuits, all the way to memory production and testing.
Now, you might be wondering, why go to all this trouble? Well, Musk claims that all the current fabrication facilities on Earth combined produce only about 2% of the edge inference compute chips that Tesla and SpaceX actually need. And just to clarify, those are the specialized hardware chips that process AI locally, directly on a device. The global chip industry as it stands today just simply cannot expand quickly enough to meet the wild demand of this new off-world infrastructure. The scale of this operation is it's hard to overstate. While the prototype fab operates in Austin producing Tesla's AI-5 chips, the full-scale megafactory plan for Grimes County, Texas is something else entirely. We are talking about a facility covering up to 10 million square meters. By utilizing Intel's cutting-edge 14A manufacturing process, which by the way packs transistors almost at the atomic level, this complex aims to process 1 million silicon wafers a month. That translates to an astonishing 1 to 200 billion custom AI and memory chips annually.
But of course, we've got to be objective here and look at the realities of building something this colossal. Constructing this full-scale facility at the Gibbons Creek Reservoir comes with some really profound terrestrial challenges. For one, analysts estimate the total cost for the full-scale facility could run anywhere from $5 to $13 trillion. Trillion with a T. Plus, local county residents have raised very real, very understandable concerns regarding the environmental impact and the massive shift this is going to bring to their rural population. So, it's a highly ambitious project, but it is definitely not without its earthly friction.
Let's look at the timeline here, because the schedule connecting this Texas factory to the surface of Mars is incredibly tight. From the Terafab announcement in 2026, it is a straight shot into volume production of AI chips by 2027. And all of this is aimed at a staggering 2030 goal of humans actually landing in pre-built Martian cities. But that begs the question, right? How exactly do these chips get to Mars to build those cities in the first place?
Starship V3, our interplanetary delivery truck.
Because look, all the AI chips in the world won't help you if you can't get them off the planet efficiently. The Starship version 3 is no longer just a rocket, it's a full-on industrial delivery truck. Standing over 124 meters tall, it's equipped with a new generation of Raptor 3 engines that pump out 50% more thrust. With a payload capacity of 100 to 200 tons, the V3 is capable of hauling entire automated Terafab factories, miles of solar sheets, and thousands of robots into space all at once. It is literally the ultimate heavy lifter for a space-based industrial revolution.
Robotic factories on Mars, building cities before humans even arrive.
So once that delivery arrives on the red planet, a massive workforce is going to be waiting. As it turns out, 80% of those advanced chips from Texas, they're destined for space. They're going to act as the brains for billions of autonomous Tesla Optimus robots. This relentless construction crew will actually use Martian dust, known as regolith, as their raw material. Powered by space-based data centers, these machines are going to process that dust to 3D print concrete-like walls, radiation-blocking domes, the whole life support system.
Imagine thousands of robots pulling a multi-year all-nighter, operating 24/7 without oxygen, just processing raw dirt into high-tech, ready-to-live cities before a single human astronaut even sets foot there.
Shielding the red planet, defeating deadly cosmic radiation.
Now, to make Mars actually survivable long-term, we have to defeat its invisible enemy, deadly cosmic radiation. You see, Mars lost its natural magnetic shield billions of years ago, which leaves it completely exposed to harsh solar winds. The sheer genius here is the plan to create an artificial magnetosphere. By using Starship V3 to deploy a massive superconducting magnetic dipole at the L1 Lagrange point, which is basically a stable gravitational spot between the Sun and Mars, we could create a planetary magnetic shield. This shield would actively deflect that dangerous solar radiation, and once protected, the frozen CO2 on Mars could actually begin to thaw, thickening the atmosphere, triggering a greenhouse effect, and basically taking the very first steps toward terraforming Mars into a breathable blue world.
Harnessing the sun's power, the ultimate energy solution.
But powering those massive Martian cities and these colossal magnetic shields reveals a pretty major energy problem. Mars only receives about 43% of the solar intensity that Earth does. Down here on Earth, our solar panels are constantly at the mercy of clouds, nighttime, atmospheric reflection, weather, all of it. But up in space, the solar energy is 100% pure, unfiltered, and relentless. It's an endlessly abundant energy source just waiting to be tapped, totally bypassing all those planetary solar limitations.
To capture all of this, SpaceX is essentially evolving into a Dyson Swarm company, bringing a colossal sci-fi concept straight into reality. If you're not familiar, a Dyson Swarm isn't a solid sphere around a star. It's actually a massive web, millions of satellites surrounding a star, designed to capture its total energy output and wirelessly beam it via microwaves or lasers precisely where it's needed.
So how exactly do you build a swarm like that? Well, by utilizing those AI robots and processing lunar silicon in factories located right on the moon. These autonomous machines will manufacture the solar harvesters directly in space. The initial plan involves positioning an astonishing 1 million solar-powered AI satellites roughly 150 million kilometers away from the sun. They're going to absorb that pure solar energy and use high-intensity lasers or microwaves to beam unlimited wireless electricity to receiving stations on Mars and eventually right back down to Earth.
Becoming a Type 2 civilization, unlocking God mode.
We have now zoomed all the way out from a tiny chip in a Texas factory to the grandest scale imaginable. By successfully building this orbital power grid, humanity actually crosses the threshold into a Type 2 civilization. This is a level where a civilization can harness the entire energy output of its host star. It's often referred to by futurists as unlocking God mode, an era of unprecedented capability, absolute control over solar system resources, and true cosmic expansion. To put this into perspective, right now, humanity is roughly a Type 0.7 civilization. We are currently struggling to manage about 18 to 20 terawatts of power globally. The leap to Type 2, capturing the millions of terawatts of the sun's total output, represents a literal tsunami of power. With this level of energy at our fingertips, greening Mars becomes trivial, and true interstellar travel to other stars finally transitions from a pipe dream into a real engineering reality.
Yet, before we pack our bags for Alpha Centauri, we really must impartially recognize the profound risks of this endeavor. Operating delicate robotic factories in zero gravity amidst brutal, circuit-frying cosmic radiation represents a monumental $25 billion technological gamble. Think about it. One major solar flare could wipe out unshielded AI satellites in an instant. Hardware failures could be absolutely catastrophic, and it is entirely possible that these massive technical hurdles could cause the early stages of this whole project to just fail completely. But, that has always been the nature of pushing boundaries. So as we wrap up this explainer, I want to leave you with this final thought to ponder. As we watch these Texas mega factories rise from the dirt to churn out billions of AI chips, are we truly ready to transcend our planet, overcome these seemingly impossible risks, and take control of the solar system's true power? It's a lot to think about. Thanks for joining me for this explainer. Keep learning, and I'll see you next time.